In this lesson, we will explore how to sketch and analyze transformations of sinusoidal functions. So we're going to bring back all our knowledge of graphing and mapping notation, and remember all the different transformations that we applied on the other parent functions, we will be applying them to our sinusoidal functions as well. So with that, let's do a little bit of a review. So transformation properties of the sine and cosine function. So the graph of y equals a sine k bracket x minus d plus c is a transformation of the graph of y equals sine of x. Now, keeping in mind all the different transformations are exactly the same, we're just now applying it to the parent function y equals sine of x. So that's going to be transformed. So reminding ourselves again, if we have an a value, we can have either a vertical stretch or compression by a factor of a. If a is greater than 1, then we know we have a vertical stretch. If, however, a is between -1 and 1, then we know it's vertically compressed. If, however, a is negative, then we know that it is a reflection into the x-axis. K represents any horizontal stretches or compressions by a factor of 1 over k. So if k is greater than 1, then we're compressing the function by a factor of 1 over k. If, however, we have a value of k that's between -1 and 1, we're stretched by a factor of 1 over k. If, however, k is negative, then we know we're reflecting into the y-axis this time. D is a horizontal translation, units to the left or to the right. So if D is greater than 0, then the whole graph is moving to the right. If D is less than 0, then it's moving to the left. This is also often called the phase shift. So instead of saying a horizontal translation, we can say a phase shift left or right and how many units. C is a vertical translation. C units either up or down. So if C is greater than 0, then we know we're going up. If C is less than 0, it's going down. This is also often called the sinusoidal axes. Okay, so again, it's impacting our function the exact same way it's impacted the other functions. So note the transformation for a sine function can also apply to the cosine and the tangent function. So as you see the notation there, A, K, D, and C impact all our graphs the exact same way. So reminding us of our mapping notation as well. So the mapping notation for the transformation of both functions is as follows. Again, x 1 over k times x or x over k, which is the same thing, plus d. So k and d impact the x values, the x coordinates. A and c impact the y coordinates. So just remembering again, don't forget our parent function key points. With sine, we know at 0, we're at 0. 0, we're at 0, then we go up to 1, back to 0, then -1, and then back to 0. Cosine is different because we start at our maximum, so it's at 1, 0, we go down to -1, 0, and then back up to 1. Okay, so these key points are very important when we're doing mapping notation and graphing transformed sine, cosine, or tan functions. So in example 1, we have sketch the graph of the function and describe the transformations that occur to the original parent function. So again, we know that the base function is, in this case, sine. So we know, and we always start with that parent function key point, sine of x. So we're going to see, we can do that first. We know again, it's 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back at 360. So think of the quadrants, 0, 90, 180, 270, 360. Keep adding 90. So we know that was at 0, 1, 0, -1, and then 0. Okay, so look, just like the previous functions we looked at, we always want to factor out the k value. So in this case, we can say f at x is equal to -3 sine. We're going to factor out that 2. Left with x minus 45 degrees, and then it's going to be plus 2. For all our functions, that is very critical. That's going to impact that horizontal translation or that phase shift. Okay, then we can identify a is equal to -3, k is equal to 2, d is equal to 45, and C is equal to 2. Mhm. So then, again, with the mapping rule, keeping in mind x, y, it's always x over k plus d, a, y plus c. Okay, so x over k was 2, so it's going to be x over 2 plus my d, which is 45. A is negative 3 times y plus c, which is plus 2. Okay, and we're substituting those different values for x from the parent function into that mapping notation. So 0 divided by 2 is simply 0, plus 45 is 45 degrees. 90 divided by 2 is 45. 45 plus 45 would be 90 degrees. 180 divided by 2 is 90 plus 45, which would be 135 degrees. So I'm sure you're noticing that we just keep going up by 45 degrees. Okay, so summing the parent function key points into the mapping notation when y is 0, negative 3 times 0 is 0, plus 2, which is 2. Well, negative 3 times 1 is negative 3 plus 1, which is negative 1. 2, negative 1 times negative 3 is positive 3 plus 2 is 5, and then 2. Okay, so we know the c value also is that equation of axes. Okay, so the scale is already created for us, which is great. So at 45, keeping in mind the scale comes going 30, we start at 45, so that's between 30 and 60. So it's 30 and 60. Okay, best idea is to always plot that equation of axes first. So it's that horizontal dotted line. So we know that's y equals 2. Okay, so at 45, we're at 2. At 90, we're at negative 1. At 135, we're back at, oops, we're at 2. Oh, why is it not staying? Okay, at 180, we're at 5. And then at 225, we're at 2. Okay, remember it's a nice, smooth curve. And that would be one full cycle of y is equal to negative 3 sine 2 x minus 45 degrees plus 2. Okay, let's describe the transformations. So again, we've already identified A, K, D, and C. Let's list them, and then we can describe those transformations. So we know A is equal to negative 3. Because A is negative, we know it's reflected into the x-axis. Right? 3 means we have a vertical stretch by a factor of 3. Okay, K value is 2. Remember, K is 2, but the scale factor is always 1 over K. The scale factor equals 1 over 2. That means we'd have a horizontal compression by a factor of 1/2. D is 45 degrees. Again, we can say phase shift or horizontal translation, same thing. So phase shift right, 45 degrees. And of course, C is equal to 2. So that would be a vertical translation. So you're telling me what translation and the direction and how many units. So down, is it 2? Positives are up, not down. Plus 2. So sorry, that should be up 2 units. Okay, what is the amplitude again? that distance from the equation of axes to the minimum, equation of axes to the maximum. So, or we can read that's our A value, and we always just describe the amplitude in positive values. So we know A is -3, but the absolute value of -3 is +3. When does one full cycle occur? Again, the difference between 225 to 45, which is 180 degrees. The maximum in this case we see is 5. The minimum is -1. The equation of axes we know is that C value, which is y equals 2, right? And the domain, again, we're doing that one cycle, or maybe it doesn't give us our restrictions. So we're going to say we just had to graph one cycle, but it does keep going, keep going. So x is an element of real. Range, however, y is an element of real, but it has to be greater than -1 and less than 5. Okay, so keep in mind this is always going to be your min. So greater than your min, less than your max. Okay, moving on to example B, same idea. Again, always factor out your k value. So let's do that. F at x is equal to 2 cos. Factor out the x would be x plus 30 minus, minus 1. So A is equal to 2, K is equal to 2, D is equal to -30, and C is equal to -1. Right, so again, now we're looking at the cosine function. So because it is the cosine function, you have to remember the key points. So y is equal to cos of x. The x values are the same, so it's 0 degrees and 90 degrees, 180, 270, and then 360. So cosine, remember, it starts at its max. So it's going to be 1, 0, -1, 0, and then 1. Okay, so using mapping notation, again, keeping in mind x, y, it's always x over k plus rd, a, y plus c. Okay, so x over k, so x over 2 plus my d, which is -30 degrees, to y minus 1. Okay, so substituting our x values, 0 divided by 2 is 0, so it's going to be -30 degrees. 90 divided by 2 would be 45. 45 minus 30, which would be 15 degrees. 180 divided by 2 is 90 minus 30, which is 60 degrees. It looks like we're going up by 45s again, so that would be 105 and then 150 degrees. Okay, substituting our y values. 2 times 1 is 1, minus 1 is 0. Oh, sorry, 2, not 0, but 1. 2 times 1 is 2, minus 1 is 1. 2 times 0 is 0, minus 1 is -1. 2 times negative is -2, minus 1, which is -3. 2 times 0 is 0, minus 1 is -1. 2 times 2 minus 1, which is 1. Okay, so let's graph that. Again, keeping in mind our scale. So again, at -30, our scale's at 30, so that makes it easier. We're at 1. And again, I always recommend just drawing that equation of axes. Y equals -1. Okay, so at 15 degrees, we would be at -1. At 60 degrees, we're at -3. At 105 degrees, we're back at -1. And at 150 degrees, we are back at +1. So this is f at x is equal to 2 cos 2x plus. So if you put the original, it's fine. let's describe the transformation. So we've already identified A, K, D, and C. So we know A is equal to 2. So that would be a vertical stretch by a factor of 2. K is equal to 2, so that means scale factor is 1 over K, 1 over 2, so that means we have a horizontal compression by a factor of 1/2. D is equal to, we said, negative 30 degrees. So that would be a phase shift left, 30 degrees, and C is that equation of axes, which is -1. So that's a vertical translation. We're going down 1 unit. Okay, so the amplitude. Again, amplitude is from the equation of axes to the max or to the min. So that distance looks to be 2, but with our equation, it's that A value. So it's always absolute value, so it's never negative. Okay, when you're describing the amplitude, that distance is always a absolute value, so keep that in mind. A period, when does one full cycle occur? Well, if we took 150 minus -30, well, that would be 180 degrees. Our maximum was 1. Our minimum was -3. The equation of axes, it's always an equation. So we would say y is equal to -1. The domain, again, with these sinusoidal functions, there are no restrictions unless they state the restrictions in the question right from the beginning. But we'd say y is an element real. Don't forget your notation. We know the minimum is -3. So y has to be greater than -3, but less than 1. Okay, looking at example 2, we have write the equation for a sine function having an amplitude of 5. So we know a is equal to 5. The period is equal to 300. And reflected into the x-axis. So if it's reflected into the x-axis, a becomes negative. So a is equal to -5. Now, to get the to get the k value, you get that from the period, because we know the period is always equal to 360 over k. So cross multiplying, dividing, 360 over your period will give you your k value. So with that in mind, 360 divided 300, k is going to equal to 1.2. Right. So therefore, f at x is equal to a value of -5 sine 1.2 x. Oops, 1.2 x. Okay, so you're taking the information given and deciding, does the equation have an A, K, D, or C? So we have an amplitude of 3. So A is equal to 3. The period is 180. So if that's the case, we're going to take K is always equal to 360 divided by period. Well, the period is 180. So 360 divided by 180, k is equal to 2. It's reflected into the x-axis, so a is now -3. Phase shift to the right, 60 degrees, so that's going to be d is equal to 60, and you're going up 4, so c is equal to 4. Okay, we're using the sine function, so we're going to say f at x is equal to -3 sine our k value, which is 2x minus 60 degrees, all up 4. Okay, now we're looking at the cosine function. So write the equation for a cosine function having an amplitude of 3, period of 180 degrees, and reflected into the x-axis. So a is equal to 3, the period 180, so we're going to take k is equal to 360 divided by the period, which is 180. So k is equal to 2. It's reflected into the x-axis, so again, a is going to become negative. So we can say f at x is equal to negative 3 cos 2x. Oh, this time they're not giving us the actual amplitude, but they are providing us with the max and the min and the period. So we can calculate using our knowledge of the equations to decide how to get the amplitude. So the amplitude is always max, just a reminder, max minus min divided by 2. The max value is 2 minus the min value, which is negative 8. Divide that by 2. 2 plus 8 divided by 2 is 10 divided by 2, which is 5. So the amplitude is 5. Okay, equation of axis, which is our C value. We're going to C is equal to max plus my min and divide that by 2. So C is going to equal to 2 plus negative 8, divide that by 2. We know 2 plus negative 8 would be negative 6, divide that by 2. So C is equal to negative 3. So we have A and C. K value, again, it's 360 divided by your period. So 360 divided by 180. So K is equal to 2. So therefore, f at x is equal to 5 cos K value of 2x minus 3. Okay, in example 4 now, we're given, write an equation for the graph using the given trigonometric function. So again, if we're doing cosine with the first, okay, so what we want to always do is identify the max and the min because we can calculate the amplitude, we can calculate the equation of axes, and we can determine what the period is. That will help us calculate the K value. Okay, with any kind of horizontal translation, left or right. So that D value, because we are starting with the cosine function, it's how far did the maximum move from the vertical axis, from the y-axis. So we're going to break it down first. Let's identify the max. So max is 4, min is equal to negative 2. So then from the graph, we see that the D value is 120 degrees because keep in mind cosine starts at its max. But let's take what is our amplitude is going to be max minus our min, divide that by 2. So A is equal to, so 4 minus negative 2, divide that by 2, which is 3. C is going to be max plus my min. C is going to do 4 plus negative 2, divide that by 2. 2 divided by 4 plus negative 2, 2. 2 divided by 2, which is 1. Okay, so we know from the graph, D is equal to 120. And then we know that K is going to equal to 360 divided by the period. Okay, so when does one full cycle occur? We can say from 120 okay, so period is going to equal to 300 minus 120, which is 180. Okay, so if we took 360 divided by 180, we know that K is equal to 2. So therefore, f at x is going to equal to A value, which is 3, cos times your K value, which is 2, x minus 120 degrees, and then the C value, which is plus 1. And definitely y is equal to 1 is that equation of axes. Okay, this time we're going to do the sine function. So again, let's start with the max. Max is equal to 3. Min is equal to, min is equal to -7. So if we wanted to know the amplitude, it's always max minus min, divide that by 2. Max, which is 3, minus our min, divide that by 2. 10 divided by 2, which is 5. C is always max plus our min, divide that by 2. C is equal to 3 plus -7, divide that by 2. C is equal to -2. -4 divided by 2 is 2. Okay. The period. When does one full cycle occur? So we'll go from max to max. If I paste that's 90. And here would be 2. So if we took the period is going to equal 2 to 10 minus 90, which is equal to 120. Okay, so again, that's how one full cycle. You're going to take max from max. That's the easiest way to decide. Take that, changing your x values. Okay, so the period is 120. So therefore, we can say k is equal to 360 divided by 120. So this k is equal to 3. Now, because we already have the equation of axes, so I'm going to say it -2. Keeping in mind that when you're using the sine function always starts at your equation of axes. So when we're looking at that d value, in this case, we can actually, because it starts, but it's going to the -1 over +1, that means there's been a reflection into the x-axis. So we can say d equals 0, and I'm going to give you 2 scenarios. D can equal to 0 if a is equal to negative. Okay, because that means you're not moving it left to right. It's just instead of going up to its maximum, it's coming down to the minimum. If, however, you wanted a horizontal translation, so in this case, we can say f at x is equal to -5 sine 3. We don't even have to put the round square brackets. We can just say 3x. And we're going to say -2. Okay. If, however, d would be, again, how far it is from the y-axis to has moved to that equation of axes, which would be, if we see here, the d value would be at this point. So in this case, d is equal to 60. Right? If we keep a positive, so d is equal to 60 if a is positive. So in that case, or we can say f at x is equal to -5 sine bracket 3x minus 60 degrees minus 2. Either or, both of these equations represent the graph given.